Hello and welcome to this video on ADAS Sensor Fusion Validation Test. This video will showcase how ADAS applications can be tested with connected simulation and test platforms. We will highlight model, software, and hardware in-the-loop tests for adaptive cruise control, lane departure warning, and object movement for closed and open-loop test capability. As a concept overview, the Hexagon Virtual Test Drive VTD Environment Simulator will simulate a driving scenario. Relevant object data for the separate sensors will be sent to the Konrad ADAS XIL Test Workbench. These simulator systems will emulate the objects in a synchronized manner for the sensors, and the sensor output can be stored or routed back to the drive simulation for performance evaluation. For our demonstration setup, we will use a continental radar sensor and a mobile eye camera sensor in a closed-loop environment. The demonstration hardware consists of the camera and radar sensors, the Konrad Multiple Object and Angle Radar Test System, and the Konrad Camera Test System. Hexagon's VTD Environment Simulator generates virtual drive scenarios. Step 1 of the demonstration shows model-in-the-loop test using VTD to test third-party ACC and ECU models. Let's switch now to the demo execution. The right screen shows the drive simulation in VTD. The left screen shows the third-party ACC and ECU model execution. As shown, the ECU model correctly identifies the object and triggers the ACC function when the object is in front of the vehicle. For the next test, the ACC model correctly re-identifies another object that arrives in the FOV as the ACC target object, despite a changing test scenario on a curved road. When the motorcycle changes lanes, the ACC model correctly re-identifies the car as the ACC object until the vehicle lane change occurs. For Step 2 of the demonstration, the same ACC and ECU models from Step 1 will be tested using the same scenario to generate real-time sensor input from the sensors and the Konrad ADAS XIL Test Workbench. Let's go to the demo execution next. For this view, the bottom of the screen shows the inside view of the Konrad Moving Angle and Object Radar Test System, specifically focusing on the antennas used for the radar object simulation. For the top of the screen, the output from the radar and camera sensors are shown together with a VTD scenario. As shown, both sensor outputs correctly match the drive scenario. The ACC model executes correctly for the closed-loop test using actual sensor output for object identification and operation mode. For the sensor tests, the mobile eye camera correctly implements the forward object identification, lane monitoring, and LDW functions according to the test scenario. For Part 3 of the demonstration, an ACC model deployed on an external ECU hardware platform will receive the sensor output in real time to show a hardware-in-the-loop test with sensor fusion. Let's go to the demo execution. The ACC ECU demonstration unit is a hardware interface board that connects to a real-time module running the ACC model. As we repeat the drive test scenario, we see the correct implementation of the ACC function with the initial object being correctly recognized at 2.5 meters by the radar and camera sensors. For sensor tests, the Mobileye camera correctly implements the forward object identification, lane monitoring, and LDW functions according to the test scenario. The Continental radar sensor output also matches the scenario, validating that both sensors and the ACC module are performing as expected. As an overview, the demonstration today showed how the Hexagon VTD and the Konrad ADAS XIL test workbench is used for ADAS tests in a lab environment. Benefits include reducing time to market by connecting hardware and software simulation efforts, customizing component and subsystem level tests for ADAS sensors, and optimizing in-lab tests before a test drive. This test setup is also used for reliability and regression tests for ADAS, testing different sensors, and ADAS functional safety tests for evolving standards like Euro NCAP and SOTIF. Thank you for watching, and please contact us for more details.